Hey everyone! Today we're diving into one of the most mind-blowing stories in climate science. Antarctica's ice is refreezing. Is this a sign that global warming is hitting the brakes? Or is it just a temporary plot twist in our planet's wild weather saga? Stick around as we break down the science, uncover the history with a graph, explore the refreezing process, reveal the major factors, and peek into what this means for Earth's future. Let's get into it. Please don't forget to subscribe to this channel. First things first, what do we even mean by Antarctica's ice refreezing? Antarctica isn't just a giant ice cube. It's home to two main types of ice. The massive continental ice sheet, that's the land-based stuff like a frozen blanket over the continent, and sea ice, the floating ice that forms on the ocean surface around it. The refreezing we're talking about here mostly refers to sea ice. This ice forms when seawater freezes in the super cold Antarctic winters. Science is all about phase changes. Think of it like your freezer turning water into ice cubes. When ocean temperatures drop below about -1.8 degrees Celsius, that's 28.8 degrees Fahrenheit, colder than your average freezer, salt water starts to solidify. But here's the cool part. As it freezes, the salt gets pushed out, creating brine, super salty water that sinks and helps drive global ocean currents. Refreezing isn't new, it's a seasonal cycle. But recent buzz comes from 2023 to 2024 data showing Antarctic sea ice recovering rapidly after hitting record lows. For example, after the lowest sea ice extent ever in 2023, just 17 million square kilometers, it bounced back with faster than expected growth in early 2024. It's like the ice is saying, not so fast, climate change. But is it really reversing? We'll get to that. Our story begins in the heart of 2024, where Antarctica decided to throw a curveball. Picture this. After years of alarming ice melt, record lows in 2023 left the continent looking like a half-eaten popsicle. The 2023 winter low was a whopping 1.75 million square kilometers below average, equivalent to losing an area the size of Texas and California combined. Soon after, 2024's winter roared in colder than a villain's heart. Sea ice expanded rapidly, covering millions more square kilometers than the year before. The question is, why did 2024 bring such a chilly winter in Antarctica? What's the deal with swirling ocean currents and wild winds? It all starts with the polar vortex, that massive whirlpool of frigid air high in the atmosphere. In 2024, it was stronger and more stable, like a tightly wound spring, trapping super cold air over Antarctica instead of letting it escape. This led to air temperatures plummeting to -50 degrees Celsius or lower, cold enough to freeze your breath mid-air. But there's more to this plot twist. Enter the aftermath of the 2022 Hunga Tonga volcanic eruption in the Pacific. This beast spewed massive amounts of water vapor into the stratosphere, which acted like a global thermostat tweak. It cooled the southern hemisphere slightly by blocking some sunlight and altering weather patterns. Combined with a shift toward La Niña conditions, the cooler phase of the Pacific's El Niño-La Niña cycle, it supercharged Antarctica's winter chill. Think of La Niña as the cool-headed sibling who calms things down after El Niño's hot-headed party. The result? Faster ice formation, tiny crystals turning into vast sheets refreezing the seas. It's like nature hit the refresh button, but remember, this is a short chapter in a longer saga of warming. As our quest deepens, we plunge into the Southern Ocean, where the Antarctic Circumpolar Current, ACC, reigns supreme. Imagine this current as Earth's biggest conveyor belt, a massive river of water circling Antarctica at speeds up to 4 kilometers per hour, unbroken by land. It's the world's strongest ocean current, stretching 24,000 kilometers and carrying more water than all the planet's rivers combined. So, how does it factor into refreezing? The ACC acts like a gatekeeper. Normally, it brings warmer water from the north, which can sneak under the ice and melt it from below, like a sneaky thief eroding a fortress wall. But in times of refreeze, shifts in the current can flip the script. For instance, when the ACC slows or changes path, influenced by wind or climate patterns, it allows colder, deeper waters to upwell, rising to the surface like bubbles in a soda. In 2024, subtle changes in the ACC, possibly linked to that stronger polar vortex, reduced warm water intrusion in key areas like the Weddell Sea. This lets colder surface waters dominate, making it easier for ice to form and thicken. It's a double-edged sword, though. Over time, global warming is making the ACC stronger and warmer, which could accelerate future melting. For now, it's helping the refreeze, like a loyal ally in our explorer's tale. No Antarctic adventure is complete without the winds, fierce, invisible artists shaping the frozen landscape. These aren't your gentle breezes, they're powerful westerlies, blowing from west to east around the continent at 50 to 100 kilometers per h, like a non-stop whirlwind party. Wind patterns are key to refreezing because they push and pull the ice. Strong winds spread thin ice outward, increasing its total area, extent, even if it's not super thick. Think of it like stretching pizza dough to cover more ground. In 2024, intensified winds from a robust polar vortex did just that, helping sea ice expand quickly. But winds also mix the ocean layers. When they blow hard, they churn up colder water from below, cooling the surface and kickstarting freeze. Conversely, calmer winds let ice consolidate and thicken without breaking apart. It's all about balance. If winds get too wild due to climate change, they could fracture ice and promote melt. For refreezing, they're the unpredictable sidekicks, sometimes heroes, sometimes troublemakers. Now, we meet the ringmaster of this circus, the Southern Annular Mode, SAM, a natural climate seesaw that influences the whole southern hemisphere. Picture SAM as a giant atmospheric hula hoop around Antarctica. When it's in a positive phase, the hoop tightens, strengthening those westerly winds and locking cold air in place. In positive SAM mode, which was prominent in parts of 2024, it enhances refreezing by isolating Antarctica's chill. Stronger winds push ice out, reduce warm air intrusion, and even increase snowfall, which insulates the ice like a fluffy blanket. Data shows positive SAM can boost sea ice extent by 10 to 20% in some years. But SAM swings both ways. A negative phase loosens the hoop, letting warmer air and weaker winds in, which favors melting. Human-caused warming is tilting SAM toward more positive phases, creating short-term refreezes, but long-term instability. It's like a plot device in our story, twisting the narrative just when you think you've got it figured out. Our quest wouldn't be complete without the supporting characters. First, fresh water from melting glaciers. As land ice melts, it dumps fresh water into the ocean, which freezes at higher temperatures than salty seawater, like adding less salt to your soup to make it chill faster. Then there's precipitation and snow. More snow from changing weather patterns acts as insulation, trapping cold and aiding refreeze. Don't forget global players like El Niño La Niña, which ripple down to Antarctica, or even ozone hole recovery, which stabilizes the atmosphere and influences winds. And one wild card. Tiny particles from wildfires or volcanoes can seed clouds, potentially cooling regions temporarily. All these weave into the refreeze tapestry, showing how interconnected our planet is. All right, the million-dollar question. What does this mean for Earth? Good news first. Refreezing sea ice helps reflect sunlight, the albedo effect, cooling the planet a bit and protecting marine life like krill and penguins. It could slow local sea level rise temporarily by locking up water. But don't pop the champagne yet. Suppose we see the trend in this graph. The Antarctic ice mass came down with regular fluctuations over decades. Here, it broke the trend a bit, and the ice mass grew with some fluctuations again. We can only call it a trend reversal if the ice mass starts growing in the way it melted down before. Earth's average temperature has risen 1.1 degrees Celsius since pre-industrial times, and Antarctica is warming faster than the global average. This refreeze is a natural fluctuation, possibly amplified by events like the 2022 Hunga Tonga volcano eruption, which injected water vapor into the atmosphere and altered the weather. Scientists emphasize it's not undoing decades of ice loss. Think of it like a stock market dip in a bull run, temporary relief, but the upward trend continues unless we act. Real reversal requires slashing CO2 emissions to net zero by 2050. Projections from the IPCC suggest that by 2100, Antarctic sea ice could shrink by 25 to 50% under moderate emissions scenarios, leading to higher seas, up to 0.5 meters from Antarctica alone, and disrupted ocean currents that affect global weather. For our planet, it means more extreme variability, hotter summers, wilder winters, and risks like tipping points. For example, if the West Antarctic ice sheet collapses, seas could rise 3-5 meters. Positively, it buys time for us to cut emissions. Renewable energy, anyone? There you have it, the science, history, and future of Antarctica's ice refreezing. It's a reminder that our planet is resilient but needs our help. If you enjoyed this, smash that like button, subscribe for more climate deep dives, and drop your thoughts in the comments. Do you think we can turn the tide on warming? See you next time.